Roots, zeros, factors, solutions. These are the common terms that you will hear when we start to learn about functions or quadratics, because they all are different terms used in different contexts, but they all have exactly the same meaning. So you should be aware of these terms very intimately, because you should not get confused that it is not anything different. They all mean the same thing, and we are going to actually use these terms here and then explain you so that you are very comfortable using these words interchangeably in any context. So for example, let us write these four quadrants, like, let's call them as roots. So here we are going to explain roots. Here we are going to call it as zeros. Let us call this as factors, and let us call this quadrant as solutions. So they're all same meaning. So here what I'm going to do is I'm going to draw a quadratic function that intersects the x-axis. So here we see that this function, let us also call, remember that a quadratic function is something like y is equal to ax square plus bx plus c. So when this function intersects the x-axis, we will have 2 points of intersection. So let's call them as P and Q. So P and Q are called the roots of the quadratic equation. We call them as roots because when you when the quadratic function intersects, the y coordinate is 0 at the point x is equal to P and x is equal to Q. So we call them as x is equal to P and x is equal to Q as the roots of the quadratic function. What is zeros? So again, let us take an example here this time. So if I have to draw, let us try to draw y is equal to x minus 1, that means x is equal to 1. So let us try to draw this one. So in this function, let us say that this is y is equal to x square minus 2x plus 1. So when this function intersects the x-axis, we know that y will be 0. So y is 0 and we get x minus 1 whole square is 0, which means x is equal to 1 is a solution. So actually, again, we can actually call them as the 1 is a root. 1 is a root. But why we call it as 0 is because if we substitute x is equal to 1, we get 1 square minus 2 times 1 plus 1 is equal to 0. So the y value is 0. So that is why sometimes people call that a quadratic function has zeros. By zeros, what they mean is that the y value will be 0 when you substitute for the value of x. So in this roots, we are actually using the term to denote the x values. So that's why we call it as roots. When we talk about zeros, we actually are trying to say that the y value of this function is 0. So that's why these two different terms have come into practice. Similarly, let us try to take another example of a quadratic equation like x square minus 7x plus 12 equal to 0. So we know that in order to use factorization method to solve this one, we will have 12 will have two factors, minus 3 and minus 4. So if I write this equation to solve using the factorization method, I will write as 12 equal to 0. So taking common factors, we see that x minus 3 and x minus 4. Let us check once again. So we have 12. Okay, so x minus 3 equal to 0. So these two terms x minus 4 and x minus 3 are called factors. Why we call them as factors is because if I were to divide this expression, the x square minus 7x plus 12, then there will be no remainder. Therefore it is called as factors. Remember, for a number, when two numbers multiply or when the number divides the number, and there is no remainder, we call it as a factor. So the word factor comes from the same thing, and it also applies to expressions, because let us take this x square minus 7x plus 12 and let's try to do a long division. So in a long division, what we do is we do x here, so we get x squared minus 4x, then this cancels out, and then this will be minus 3x plus 12. So now we write x minus 3, so minus 3x and plus 12. So there is no remainder, so the remainder is 0. So when a term divides another expression, we call, and there is no remainder, we call it as a factor. So that's why, algebraically it is commonly used as factors, because it comes from the word factorization, because factorization is a very common technique to solve quadratic equations, and from there we started to call factors. So remember that when we call factors, x minus 4 is a factor and x is equal to 4 is a solution, which is the next term here we are going to use. So again, carrying over from here, when we have x minus 4 times x minus 3 equal to 0, and this is a solution for this equation, the reason is because x minus 4 has to be 0 or x minus 3 has to be 0. So this gives x is equal to 4 and x is equal to 3. So let us substitute this x values there. So if I substitute for 4 in x, 4 squared minus 7 times 4 plus 12. So let us see what happens. So 16 plus 12 minus 28 is 0. So we say x is equal to 4 is a solution to this equation. So we see how all these terms do make sense, and but they all mean the same thing. When I say something is a solution, I also mean it is a root, because graphically that is what it is called. Graphically, when you represent a function and then it intersects the x-axis, we start calling them as roots. We call them as zeros because the point where x is substituted, y becomes 0. Therefore, it's called a 0. We call it as factors because we use factorization method to solve, and we will see that sometimes an equation can be factored into one or more factors. So here we have two factors. So x minus 4 and x minus 3 is a factor, and solution because when I substitute back when the values of x to the main expression, the value will become 0. So that is called a solution. So all of these terms are exactly, the meaning is same, and whenever somebody uses this one, you can really understand that they all mean the same thing. Because if somebody says x minus 4 is a factor, you should be quickly able to say that x equal to 4 is a root, or x is equal to 4 is a solution, or when 4 is substituted into the expression, it is y value is 0. So that is the meaning of root, zeros, factors and solution. Even though these are very seemingly simple terms, a lot of people get confused when some of these terms are used, and you should be aware that this is very common practice in mathematics to use these terms interchangeably when you sometimes try to show them pictorially or graphically versus when you do algebraically. These terms factors and solutions are commonly used in algebraic notation. We call them as roots or zeros when we talk about a function in a graphical term.